kind of historical evolution, more or less like the paper we wrote. But then I will talk some different ideas about the evolution of Lua, talk a little about the evolution of the concepts behind Lua, like how Lua evolved related to portability and embeddability and things like that. Then I'll talk a little about the evolution of a very few particular features, just to see how we can focus on some particular points in the language and see how things interact and how things happen. And in the end, I will talk a little about the cost of evolution and the cost of new features and things like that, more or less like what we have to think about when we try to change the language. Well, I am Roberto. Luis Henrique, many people don't recognize him. He's LHF from the list. And Valdemar, unfortunately, couldn't come, but so we are the authors. So I started from the very beginning of Lua. I don't know how many people here are familiar with the beginnings. We started, well, actually started in '93, but in '92, TechGraph, there is a big project of PUC, the university in Brazil. It's a partnership with Petrobras. There is the main oil company, it's a Brazilian oil company. And they have a problem for graphical data entry programs. They have old legacy code in Fortran, and they wanted to write programs that create data for those programs that we could enter the data in graphical format. So Luis Henrique and was Lula, yes, another guy there, created this language, they call it data entry language. There is a very simple language to describe that kind of data entry. There is a separate file, a meta file that describes the graphics stuff, and then this file, this is the language, described that name gasket related to the image, and then describe what kinds of fields you have to fill, and what's the type of that data, and things like that. And soon they started to need other facilities like conditional behavior or validation of some fields related to other fields, and limits and things like that. And also they wanted some kind of abstraction facility, some kind of basic arithmetic facility, so they could, for instance, say that gasket here is big, larger than some addition, or 2 plus something, or all kinds of arithmetic facilities. And then a little later, I started working at TechGraph in a very different project that was called the Programa Gráfico Mestre. I don't know how to translate that. And mainly what we wanted to do was something very similar to XML, but there wasn't XML at the time. We wanted to be able to describe some kind of complex structures. We wanted data to describe this kind of graphics. So we wanted to say there is that much columns, each column have that kind of data, and there is grids or no grids, there is that kind of colors, that kind of lines. There is things they call it backups. There is when, I don't think there is backups here, there is when the scale goes wrong, it must go back and then it changes scale automatically. Then all kinds of complex structures that we wanted to describe. And then we started creating a little language that we called Sol, it's simple object language, to describe that kind of structures. So this is we started implementing Sol. This is a kind of, we could describe that there was a type track with a field X, a field Y, that should be numbers. Y had a default value of 33, and there is Z, there is no type, it was an untyped value. And we described another type line that has a field T, there was a track, and another field Z, there was a number, and then we could create objects that should satisfy those types. And the language checked that the fields without the full values should be a new value when we declare the objects and things like that. But we never actually used that language. Again, we saw it has some big limitations. Again, we needed abstraction mechanisms. We needed some kind of procedural facility sometimes. And then we met and we decided that we could create a single language that should be able to solve both problems. So it should have some powerful data description facilities, mainly for Sol. But also it should be a complete language with full abstraction facilities and usual syntax and things like that. And mainly something that it got from Sol, it should be what we call an extension language. It should be provided as a library. So since the beginning, Lua was born as a library that could be attached to different applications, and the applications could use the language for specific things. So the first version that later we called version 1.0, it actually was not a version. I don't think even we had any kind of version control at that time. We just wrote the code and started working. Later, I don't know how we recovered that version. It's from June, July '93, I think. And it was a standard implementation. Actually, who wrote the first code was Valdemar. I was kind of advising him in the code, but he wrote with YAC, standard tools for writing a language. And the main requirement at that time should be simple, should be very simple, because we wanted to write it fast. It should be extendable, as I said. It should be portable. That was a kind of a strange requirement at the time. It was related to Petrobras, the oil company, because it was from government. It had very strong restrictions of the kind of equipment they can buy, and so sometimes they had to make a, how do you call that, a licitation? I don't know. Anyway, some kind of, they couldn't say, I want to buy that equipment. They had to say, I want to buy a general equipment, and who gives the smallest price, that's the one I have to buy. And so they ended up buying all kinds of different operating systems of kind of different hardware. And then when they wanted software, they wanted software that could run on all that different machines. So that's why we needed to write very portable code. Soon, Lua 1.0 was a kind of a success. At least it was really used in that two applications. It really solved the two problems. One of those applications, the PGM program, graphic math, is still in use today. They still use that program to write oil profiles of oil wells. And soon TechGraph, other groups in TechGraph were interested in Lua, wanted to use that for different stuff. And soon we needed the main requirement that they wanted a faster program, mainly because they started using Lua to describe not only not only to describe that part, but they also started using Lua to describe the graphical images themselves. So sometimes they have, in the very beginning already, they have some Lua, well, we could call them programs, with some million lines of code or things like that. Usually, I mean, for a meta graphic, it's common. If you think about a program, it's very large program, so the compiler should be very fast and things like that. So that was the main change from Lua 1.0 to Lua 1.1. And we also created the first license of Lua. We put it public distribution in FTP, and it was free for academic uses, but it was not free for commercial uses. We thought that we could sell Lua at that time, but shortly after we gave up that idea, and then Lua 2 was already free license. And Lua 2 started in, I mean, there was a long evolution of, there was Lua 2.1 to 2, there was no 2.3, I don't remember exactly why, and then 2.4 and 2.5. Lua 2.2 was a very big change in the language, was when we introduced it kind of, at that time a lot of people thought that the language should be object-oriented. At that time, 93, 94, 95, language should be object-oriented. If it's not object-oriented, it's not a language. But we resisted that idea, but kind of so we tried to offer support for object-oriented programming, but not to turn Lua into an object-oriented language. So in Lua 2.2, we introduced fallbacks that later evolved to meta tables and meta methods through tag methods that we do in Lua 4, Lua 3. We also introduced the colon syntax for sugar for method calls and method definitions. So the basics for object orientation came in Lua 2.2. Lua 2.5, Lua 2.4, starting Lua 2.2 and then in Lua 2.4 introduced the basic API for debugging, for the introspective API to allow debugging and other tools, profiling and things like that. In Lua 2.5 we introduced pattern matching, and the very first uses of Lua for dynamic pages that I think people talk a lot in this workshop started already in 90. We started actually, I think, in 94, even before Lua 2. But in 95, we already have several tools for writing. We have even some real sites at PUC working with Lua. At that time, it was called HTML Lua. Later came the CGI Lua. During Lua 2, I also started some kind of we call international exposure, some kind of. The very first homepage of Lua was in my homepage, was www.Rio till Roberto /Lua, and we started some email contact with other users. We started to learn that there was people outside PUC and mainly outside Brazil using Lua. And then in June 96 and then later in December 96, there were two papers about Lua. Of course, one is an academic paper, the other one is much more important, the one in Dr. Bob's, the one that really showed, the first paper that really showed Lua to a lot of users, and was when Lua started to be used for games, for instance, to Greg Levsky from LucasArts. And in the beginning of 97, we started a discussion list about Lua. The main point of the list was that at that time, there was already, not lots of people, but frequently we got questions about Lua, and we thought, well, we create a list, then other people can answer those questions, then we do not have to answer them all. So that was the main motivation for the list. I think it's still a very good use for the list, and actually it's not that we do not want to answer, but usually you get much better answers from the list than from us. And this is just a story. A lot of people ask, nowadays it's not that common, that question, but for a long time it was very common to ask why we do not have news groups. And it's funny that by the end of 97, we already said, oh, we have more than 100 subscribers. Should we create a com.lang.lua news group? But then we gave up. It was too complicated. We didn't know if we would have enough users to justify the news group. And at PUC, at that time, it was not very easy to access news groups, so we stayed with the discussion list, and till today we think that the list is much easier to use, and it's much, I think a lot of people in the list prefer the list. Of course, this is a very biased people, but so we always kept the list never. Lua 3 started in
2997. The first time traveling version.
Yeah, no, that's wrong. I'm not sure, but I think that's wrong. The main change to Lua 3 was for Lua 3.0 was the tag methods. That was a change of the old fallback. I'm not going to talk about the technical details, but it was a change related to that. Actually, it's not written there, but Lua 3.1 was a very, very big change internal to Lua, a whole restructure of the code. Anyone here that is familiar with the code base of Lua can can read Lua code without problems up to 3.1. I mean, the names are more, the files are all with the same names. There are new files later, but you still, in Lua 3.1 you already have l2.c, lvm.c, all those files. The names of the functions is Lua uppercase letter related to the module and things like that. Before that, up to 3.0, the code base was more or less exactly like it was in Lua 1.0. So there was two very different families of Lua code. One starting 1.0 up to 3.0, then 3.1 till today. In 1998, we created the Lua logo. And in 1998, through Cameron Laird, there is a guy that writes about scripting language. He wrote that the first clause here, its user base is also small. There might be only a few tens of thousands of Lua programmers. For us, that was a very, very big base. I mean, we had no idea that we could have more than 1,000 Lua programmers in the world, and then only a few tens of thousands per thousand. It was very, very big. Then Lua 4. The main point of Lua 4 was the new API with different states. That was something that we were discussing since, I think, since Lua 3.1. There's a lot of proposals, but it was a very big change, so we were kind of afraid of changing that. But that change was mainly related to something that only now people are starting to use. The new state that was related to different processes. You could do multi-threading using different Lua states for each thread. But the discussion started long ago, long before we released that version. There was an independent release of Lua with independent states that was by Eric. Yes, Eric made one, and we did an internal release too of Lua with multi-states that we use in CGI Lua. But then only at Lua 4, sometime later, we made that official Lua. It was a very, very big change, maybe the biggest compatibility problem we had in Lua. For instance, tech graph, almost all tech graph never changed from Lua 3.2 to Lua 4. They thought the change was very big. They kept with Lua 3.2, and many years later, when there was already Lua 5, they started migrating directly to Lua 5. They never migrated to Lua 4. Also, in 2001, we started to be somehow recognized in Brazil. Started to arrive some news about Lua, mainly because Lua was being used in the United States. So this is very important in Brazil. So we have to be famous outside, so we could be famous inside. And then in 2001 we got the site. It was a present from Jim Methods. For a long time we wanted to the domain Lua.org, but was a time it was already taken, and then he bought the domain and gave to us. Was a very good thing. For a long time we thought about different domains. I registered lualanguage.org, and we thought about different names, but we never thought Lua.org is so good a name, so we should have it, but we had no idea about it. And then a few months later, John Belmont created the Lua users.org. There is also a very important site. And Lua 4 was a very big break from previous version, but on the other hand was a very stable version. After 2 years, there was just a single release that wanted to fix bugs. But soon we started Lua 4. We soon released Lua 4.0. We already started several plans for 4.1. We released the 4.1 alpha. I don't remember when, but there was a lot of discussions about 4.1, but actually it never finished that because there were so many changes accumulating that in the end we go straight to Lua 5. And it's funny that there was many big changes from 4 to 5, but the main one that made it become 5 instead of 4.1 was the modules, the idea that all standard libraries should be inside tables, because that changed the look of all programs. I mean, practically all programs that use functions should have a prefix before those functions. But also Lua 5 got coroutines, lexicoscoping, register-based virtual machine, all that we were working during the stability time of Lua 4. And finally Lua 5.1, we got the incremental garbage collector and the kind of adjustments to the module system, I mean the final steps for a good module system. It's difficult to say that, but I would say that Lua 5.1 or Lua 5.0, even Lua 5.0, is a kind of much more finished language than previous versions. I think when we finished Lua, immediately after we finished Lua 5.0, we started working on a new version. That was very common. We usually do that. But the main point of that change was the incremental garbage collector. So it's kind of more an implementation stuff than some kind of language change. And we ended up changing several things related to modules, but because module was a very new thing in Lua 5.0, and there was a lot of return from uses and things like that, so we changed that too. But after we finished Lua 5.1, we didn't start working on a new version. So I think this is the first time that happens, that we finished and it's okay now we can take some time to think what we need next, and so it's a kind of, we are more stable, at least I don't know if the language is more stable. So now I'm going to talk a different view of Lua evolution. As I said in the beginning, I'm going to discuss a little the evolution of the different requirements of it. As our main idea here is to stick to ANSI. And when we started, that was a very hard decision. I mean, when we started in '93, it was very, very common C compilers that were not ANSI. For instance, Sun, I worked in a Sun at that time, and it didn't have the standard C compiler, Sun compiler for Sun OS 4, pre-Solaris, was Kernighan reaching. And that time was very common code with some macros that could adjust, you could compile it as Kernighan. But we decided, no, we are going to create ANSI code and that's it. So we got a GCC compiler For some, that was a very hard decision at that time. And since then, we learned a lot about ANSI. For instance, now when we are preparing this talk, actually when we were preparing the paper, we compiled all versions of Lua since Lua 1.0, and the first versions could even compile on Linux. Usually very small details, but they, for instance, there is an inclusion of a floating point.h file. There was a use of stdin in static declarations. So in Linux, that's a kind of macro that cannot be used. The document, the answer is not very clear about whether we could use that or not. But anyway, it's not a good idea. But then after Lua 2.2 or 2.3, more or less, then it kind of got stable, and then all versions now compile. After that, compile without problem. And since then, we learned a lot about ANSI. And the good thing is that compilers usually also learned a lot about ANSI. In the beginning, we still have some problems with compile with different things in compilers, wrong compilers mainly, but usually the compilers are much better, much more closely. As the new standard appears, I think they have more room to error on the new version, so they get the old version right. So now things are much easier. And there's also, we have been trying, this is not something that we have as a goal, like in that version we are going to achieve that, but it's a general trend to move from what's called a hosted implementation to a freestanding implementation in the core. So we try to use as little as possible of the standard C libraries, mainly those related to operating system facilities. So we moved all I/O outside the core. This took a long time. We started moving error messages. Then we moved the do file, load file out of the core. We started moving all kinds of I/O operations outside the core. In Lua 5.1, we moved memory allocation also outside the core. So it's a slow move. Still, if we want to really be freestanding implementation, we should avoid mainly all library stuff. Usually think that libraries that we can recreate in C, like string moves or things like that, it's not a problem. You can write them in C if you need. So currently, the core is mostly or mainly completely free of operating system stuff. But we are not completely free. On the other hand, we have load lib much more supported than load lib started in Lua 5.0 as a kind of extra facility. Now in 5.1 it's part of the module system. So we always say that this non-portable feature is kind of the mother of all other non-portable features, because once you have a load lib, we can load non-portable modules inside Lua. So if we can support that, then we are free to not support all other stuff. But it's not an easy decision. The module system has several things more or less not exactly portable. We have some declaration like a module even the notion of directory is something that is not portable. The directory separators and things like that. LuaConf.h has lots of if-defs, so there is a lot of different things. Although this is very important. In Lua we have a mode ANSI that we can, the if-defs change to it. I mean, we always can compile Lua without the use of any specific stuff. But we do use some specific stuff sometimes. And another thing that it's sometimes a problem, this was a kind of rule in the beginning, and we gave up a little is the use of strange things in the official API. For instance, like the use of structs in parameters of the API or the use of hierarchies. Now we are using them, but still in very restricted places and very few functions. Mainly you can use the main API without needing that stuff. That stuff is problematic because if you want to translate Lua to other language, not to C, for instance, to interface Lua to Fortran or even to Java in other languages, usually this stuff gives some problems. So we try to avoid. And as I said, we accumulated lots of experience in this road to portability. For instance, we had all kinds of problems with names. Now our main rule is never use a common name, mainly in the API. For instance, we use size was the name of argument, and the compiler complains of size is some macro or something like that in some, I don't remember which system. Object is kind of almost reserved word in the Mac, and X, the Microsoft Visual the Visual C++, at least in some version of Microsoft, assume that X is the X mathematical function. It does it in line, so it uses as the name of a variable. We also have problems. We have a lot of problems with warnings. We try to compile without warnings, but there is no standard way to avoid warnings. For instance, in some systems we do exit and then a return, and then the system gives a warning that the return cannot be reached. So we remove the return, and another system says, oh, there is a function that does not return anything. So we have all these problems with warnings. Some, I mean, it's very known. There are warnings that we have standard ways to avoid, like if you have a sign in if, you just put an extra parenthesis. So there should be some way to do that for all kinds of warnings. And currently, we are having problems with compiler writers that pretend to be language designers. So for instance, in some 3 years ago, we started having problems with temp name in Linux, that they insist that temp name you should not use, and although this is part of the ANSI, and there is no way to turn off this warning to say, I know what I'm doing that because I want to do that, but they insist. Now, very recently, we started having some problems with string functions in Windows, that they insist that you should not use string copy or string cat because they are dangerous. Again, I don't know. I think there is some option in the compiler, but there is nothing in the code that you can write. I know I really want to use that function. I did all the tests to know that the size is correct. But, so this is recent. This kind of problems, we didn't have them before. And these are kind of examples of problems we had in the past. For instance, that kind of code while is alpha star S++. It's very common to find this code in a lot of places, but it's wrong because usually if S is a string, is a char, is a pointer to char. In most systems, char is assigned value, and so if you have anything up 127 in the contents, it becomes negative, and by the standard you cannot use is alpha over a negative value unless it's end of file. We had this problem in Lua 3.1, I think, or Lua 3.0 in Solaris. It really crashed if you use alpha with the negative value. We had to release a emergency 3.1.1 or something like that. I don't remember exactly the version because it crashed almost immediately in that system if you try to do something with isolating char sets. This also, it's not so common, but also it happens sometimes. You have a pointer to an array and it goes downstairs up to the first value, but when it crosses below the first value, it can be not valid anymore. C does not ensure comparison of pointers outside an array, unless it's one more than the last one, but one less than the first one, it does not ensure. So we had also this problem with some systems. Recently, we had some problems with the union of pointers and pointer to unions, because the correct way in ANSI to, if you want to simulate subclasses or some kind of subtypes, you should create a union with all those stuff there and use a pointer to that union, so the compiler can detect that you may be changing something of a different type when you change something of another type. When you use a union of pointers, it does not detect that, and the compiler can create what we should call wrong code, but it is right. I mean, we are wrong, the compiler is right. Well, embeddability was something that also has some evolution. The main point of evolution of embeddability is the portability. I mean, the main first thing to embed Lua in other applications is to be able to compile Lua. Usually use Lua embedded in other applications in different hardware. So the first thing is that Lua should compile in that hardware. The freestanding implementation also is very useful for embeddability, because we do not access the operating system without the kind of the control of the host application. For instance, memory allocation, the host can decide how you should allocate memory, where you should allocate memory, and things like that. Weak references was something that was created since the beginning, mainly for embeddability. The main problem we always had in Lua was the problem of we have some value in the host, some C structure, and we have a proxy in Lua, and we want to refer to the other, and we have that kind of cycle. The garbage collector cannot detect this is a cycle because one of the structure is outside its control. So we need some kind of weak reference, usually from the C structure to the Lua stuff. We need some weak reference that does not avoid the collection of the proxy if it's not preferred anymore. And it started as non-lock references in Lua 3, I think, and then it evolved to weak tables. User data also has different evolutions to user data. The main idea of user data, of course, is embeddability, to be able to represent host data inside Lua. And independent state was also very important for embeddability. Now host can create a state. When it doesn't need it, it can destroy the state. It's a very, also something that we have paid a lot of attention, that when we destroy a state, we really destroy everything related to Lua. There is not a single trace of the past. So this is, we free all memory, we unload the dynamic libraries, we do, I mean, all cleanup that need to be done. This is also important. Well, simplicity is kind of difficult to say about evolution of simplicity. At least we try to keep simplicity, and usually it runs against all the other aspects. It's difficult to keep portability and performance and things like that, and simplicity. So here's a very brief comparison of the Lua 1.1 and Lua 5.1, and we see that more or less in 13 years it grew 4 times. So it's at least it doesn't look like an exponential growth of it. It is an exponential growth. It's a very small number. And also this break of the core and the leaves made Lua much more modular. At least they are. This is something that started in 3, something I don't remember, but now there's a very clear line. The libraries are really outside Lua, are completely independent of the core. The core is completely independent of the library, so we're kind of 2 different stuff, so the complexity does not add. So this is a very simple example of comparison of simplicity. This is a very, very, very simple Lua interpreter in 1.1. Namely, we needed to open the standard libraries. At that time, there was only the I/O libraries, string library, and math library. And we Lua do file a name, and that's all we needed. We didn't have to open states because there was only one state, so it was automatically open. We didn't close states, so we didn't really assume that the program, the operating system, was going to release all things that we used. So it's a very, at one hand, it's very simple, but it's also very restricted what you can do, what you assume, things like that. And now the same program, equivalent program in Lua 5.1. It's not much longer, but it's the first change that it uses a lot of, not a lot, but at least two functions from the, so three functions from the auxiliary library. So even to create a state now, it's not that easy. At first we have to create a state. Then to create a state, it's not that easy because we must provide an allocation function. Then to open libs, now we have some 7 different libraries. And a very good idea, but it's, of course it's not as simple as a primitive file. We have first load the file and then call the function that was created and we load the file. And even to load the file, because the core does not use I/O facilities, we cannot use the core to load the file, so the core only provides a generic load, and we must call that generic load with a loader function that reads the file, so we use again the auxiliary library to provide this auxiliary function. And if there is an error, we must print the error, again, because the core does not do any I/O, so we cannot print the error by itself. And finally, we must close the state, because we want to release everything that was allocated by Lua. So this is the price of evolution. I mean, it's difficult to keep as simple as it was. It's a very, very brief review of performance in Lua. So I have no idea why Lua 1 was that fast for Fibonacci. I just measured that, but I didn't have time to understand what was happening there. But one thing is that it was very, as I said, it was very, very, very simple, where our messages were much simpler. It didn't have a lot of stuff that it has today, like it couldn't reallocate the stack, it didn't have var arguments, but I don't know why it was that fast. And heap sort I wasn't able to run because it didn't, Lua 2.4 didn't provide even a random function, so I should have to make a lot of changes. So this is just a general idea. Usually we got some improvements in performance, but it's not, I mean, it's difficult to say, oh, it's always better and better and better. We have a lot of trade-offs that we must make. Well, now I'm going to see just the evolution of a very few features. First one is the evolution of functions. Functions is something that really changed a lot along Lua. I think it's one of the main trends of Lua is this way functions evolved. So it started, since the beginning, Lua was first-class values, since the very first version, but they were, I mean, to be first-class values is very short of what they are today. So it's 1.0. A main difference is that function definition in 1.0, it was a kind of special thing. It was not an assignment as it is today. So for instance, that if you do print A, and after that we define the function A, we set the correct value of print A, because when we compiled Lua, then we created that A variable, and then when we run, A was already declared when we got that. But Well, I think this was mainly a bug. We could not print the values of Lua functions. It said that I cannot print that value, although we could print the values of C functions. So this looks more like a bug. But mainly we could not, for instance, write things like that. We could not, of course, create local functions because chunks could not have local variables. So we can only declare functions with local names. So it's very restricted way to define functions. In Lua 2.2, as I said, was the version that started the OO facilities. So function definition became a real assignment. As an assignment, it could have almost all kinds of different names here. At that time, it was everything that could appear in the left side of an assignment. We also introduced the sugar syntax for the column. So there was a lot of changes of the notion of functions in Lua 2.2. Later in Lua 3, we introduced var functions. Up to Lua 2.5, there were two different types of C functions and functions, although we could use them, we could call them exactly in the same way, but they were two different types. In Lua 3.0, we unified them, they became only one-time function. And Lua 3.1, I think, was the biggest change, that Lua 3.1 introduced anonymous functions and up values. This was the first version of what became lexical scoping. That was maybe the big change in the way of functions in Lua. And finally, in 5.0, we introduced proper lexical scoping, tail calls that turned out to be, I don't think it's very important, it's very used, but it's a nice facility. And in 5.1, it came the new var expression here, so change not important. Another important trend is the way that chunks evolved to become complete functions. In the beginning, chunks were kind of completely different from functions. In Lua 4, chunks started to become represented as functions because of the debug API. We should be able to debug the main chunk, and so it had to be somewhat similar to functions, so we didn't have to have very different debug facilities for functions and for the main chunk. So they started to behave more or less like functions, although, for instance, there was a kind of a bug, because through the debug interface we could capture the main function, but it was released immediately after its execution. So if we captured that and tried to call it again, it would be a crash. In Lua 2.5 and Lua 2.5, chunks could return values. In Lua 3.1, because of anonymous functions, of nested functions, chunks become quite regular functions. First, because in Lua 3.1, it was nothing special for a function to have other functions inside. So the main chunk could be a function and have other functions inside. Also, it could have local variables, again, mainly because of up values, so it became a very useful facility to have local variables in a chunk, that all functions inside the chunk could use those local variables. And finally, in Lua 5.0, we broke the two into a different load and a call, and then chunks became fully functions, and we load a chunk, we get a function, and then it's a function exactly like any other one. Here's a very brief view of the evolution of error messages. In the very beginning, the typical error message for that program was that Lua, the expected type at conversion to number, was not very useful. But in the beginning, we had a pragma. I don't know how many of you met them, that we could introduce a dollar debug in the beginning of a program, and then we got much more information about the bug, although the message was still an expected type at conversion to number. But the pragma made Lua run much more slowly. So this is one of the points of that benchmark, that all those benchmarks are without the pragma, so it could run faster, but if there was an error, kind of difficult to trace it. And there was a lot of problems with this debug. A lot of libraries were released with this debug, or sometimes we wanted to debug the library but didn't want to debug the host. Sometimes we did want to debug the host but without the pragma, so we tried to, you can turn the pragma here and turn off there, and things like that. It was very messy. So there was, I think I'm going to, yes, so this is the evolution. In 4.0 was the main change, that we wrote a kind of symbolic executor that could find more information about what kind of operation you were doing. We could find the name of the value that gave problem. For instance, here is the global Y, that was a new value, so this was the main improvement, but that's not. And now we're going to discuss what are the costs of a feature. This is a very important discussion. That usually it's very common. People, well, most people when propose a feature, just propose, why don't you put that in Lua, and that's all. And they think, oh, I have an implementation. So now it's very, very easy. All you have to do is put that implementation into the code and everything it's done. And it's sometimes the implementation is very easy. So there is no other reason now not to put that into the code. So the main point is that through the evolution of Lua, one thing we learned is that the implementation is a very small fraction of the cost of any new feature. With very few exceptions, implementation is kind of the easy part. Then, what you need for a new feature? You need documentation. Not only must be done, but it must be possible to be done. A lot of features, I mean, you have no way to document them in simple and precise ways. Usually a good documentation should be independent of the specific implementation. This second point, for instance, was a big problem for incremental garbage collection. You should be able to test the feature. You should be able to maintain the feature. You should be able to test all aspects of them. And of course, any new feature is much more things that you, I mean, as I said, the point of maintenance. Even if you test them, it is correct, it's a lot of more chance to fail in the future. I mean, the whole problem is much more complex with each new feature. Another big point of features is conceptual integrity, how this feature matches other features, how they interact, how they relate, how the documentation of them are related, and things like that. This point is very important, the impact on design space of future evolution. Sometimes you have a bright idea, oh, this feature is fantastic, and then you implement them, and later we realize, oh, there is this fantastic feature, this is much better, but we cannot put that because the two cannot work together. So we can put that if we remove the other one. But so this is a very big impact. And of course, there is a very big impact on alternative implementations. And when we want to change the implementation of some stuff, but we cannot do that because there is some specific facility that the new implementation cannot support. And if Lua did not have that particular feature, then we could use a better implementation for some generic. So for instance, here is a very brief discussion of what's the cost of multiple returns. Actually, Lua has multiple returns since its first version, so this is nothing that we thought about at the time, but it's something that we could think about now, what's the cost of it. Of course, a very good feature, I love it, I really use that a lot, but it does have a lot of hidden costs. First, the documentation, for instance, is kind of strange, the documentation of multiple returns, because you mainly do not document multiple returns. You document how a function with multiple returns behave in some circumstances, how they behave in multiple assignments, how they behave in other function calls, and things like that. There is the point of conceptual integrity. I'm not even saying that now it does have any kind of conceptual integrity, but I think it's at least it's better than it was before, and it took us a long time to get to the current design. In the very beginning, we could do the call a function with another one, and the multiple returns here were multiple arguments to the outside function. In Lua 2, we removed that feature, so multiple returns could only be useful in multiple assignments. And that feature came back in Lua 4. And only in Lua 5 we introduced the idea that you could use a multiple return inside the constructor. And then we have a kind of conceptual integrity that is that idea that in any place that you have a list of expressions, the last one can be a function, and all returns returned by that function is part of the list. So we have a kind of unifying explanation, but that it took us all that time to come to this, not only to this idea, but to be able to implement that work that way. It had a big impact on design space. For instance, in return of C functions, when we introduced the multiple, not the multiple states, but the stack API, we had this problem that first there is that int return of C functions that we must return how many values in the stack are being returned to Lua. This is a kind of strange, and we only need that because functions can return multiple values. Otherwise, you just get the top value on the stack, which would be much simpler there. And also to keep some kind of conceptual integrity that made us that resume yield should allow multiple values, because the values that you pass to a resume are the values returned from a yield. If we have only one return, then that's much easier. Resume also pass one value here, return one value there, but we keep the integrity. We should be able to pass multiple values around here. And it had a big impact on alternative implementations, of course. One point that's still kind of a problem today is that when, for instance, in that example here, when f calls g, when g returns, we have no idea how many values there are in the stack. And this situation, this is related, are the only places in the virtual machine where we have no control of the stack. In all other parts of the virtual machine, we know exactly how many elements are in the stack. We know at that point the stack has 7 values, at that point the stack has 10 values. We know the maximum size of the stack for each function, but in that point we just have no idea what the stack is. So for instance, when you think, a very good idea for Lua would be to break the stack instead of using a huge array for all stacks of different functions, to use different arrays for each function, then we have this problem that when a function returns multiple values, what should be the size of the stack that is calling that function. So there's a very big impact on the design space for. Another problem, tail call implementation is again much more complex with Lua. I mean, it's not anything really conceptually difficult, but it's much more complicated, the details. And we have a lot of problems when we try to implement Lua in different virtual machines. We cannot use the primitive returns of the virtual machine. For instance, we try to put Lua in the virtual machine of Java. You cannot use Java functions to represent Lua functions, or at least you cannot use the return of a Java bytecode to represent the return of a Lua function because of this multiple value products. So this is a very different stuff, the cost of incremental garbage collection. This one has practically no impact on documentation. It's almost transparent in the documentation. It does have a huge impact on testing. Is what I've mainly, the main problem is how to test. Even today, I think it's probably the place in Lua with more chances to find bugs is the incremental garbage collection. It's practically impossible to create all kinds of conditions. We had to write a lot of code only to test the garbage collector. It doesn't have a big impact on design space, again, because it doesn't have a big impact on what the user sees, although it does have some impacts, for instance, how you can implement finalizers, what we can do with tables. Of course, the way the garbage collector is implemented may have some impact here. And it does have a big impact on alternative implementations. The implementation of the collector is kind of spread all around the code, and it does a lot of assumptions about different things. So very inside structures in Lua are kind of committed to the garbage collector. If you want to change those structures, you have to rethink a lot about the way the garbage collector is implemented. And finally, the very small example, but again, it has its cost. What's the cost of string sub? There is the function that extracts substrings of a string. This is just to show that even very small details can have impact. This function was present since Lua 1.0. It's a very innocent looking function. Okay, we get a string, a substring, and then it gives a string and indices, and it returns the substring of that string between those indices. But that function defined the meaning of string indices in Lua. In Lua 1, I think that was the only function that had this idea of string indices, of integers that somehow refer to positions inside the string. And it set the tone for all other string manipulation functions in the future. And for instance, currently we have this kind of problem that string find of a pattern returns two numbers, and it's almost the same of string match of the pattern with two position captures, one before and one after, but it's not exactly the same. Why? Because the way that function in Lua 1.0 defined the indices as the index of the first character and the index of the last character, and not the index of the last plus one or the index of the size or any other options. For instance, icon has a very interesting way to index strings that they say that the indices actually point to the spaces between the characters and not to the characters themselves. If you had used them, this thing would not happen. So I mean, there is a lot of options there, and for at that time we did not think about that, but when we want to change the future, then we may have this kind of problem. So I think that's it. Well, now I think everybody knows about now. Some just some advertisement. Anyone that can buy the reference manual, please do. It's a good way to help the Lua team. Now the price is lower. Finally, we had some problems with the distribution. Now it's okay. Well, this is just that I'm listing all books about Lua, and there's two. Well, I'm kind of have some problems. The last announcement I made in the other workshop about Lua books did not really happen, but I think this one is going to happen. Very soon we are going to have the German translation of the Lua book, Programmieren mit Lua. And it's announced for the beginning of next year we are going to have finally another book about Lua. And one of the authors, Aaron Brown, is very active in the list. He's seems a very competent guy. I hope this book is a good contribution to the Lua bibliography. It doesn't have another cover. So that's it.
Any questions?